what is going to happen, so if these are the parent functions, and there will be some problems where I actually provide you with the parent function, and then I ask you to graph the transformation. And so if I gave you this function right here, g of x is equal to absolute value of x plus 3. Notice the plus 3 falls on the outside of the function. It's not embedded inside the square root. So what's going to happen to every point on this graph? It's going to get shifted up 3. So 1, 2, 3. Now, for all of these graphs, when you are graphing on the MyOpenMath system, you need to plot 2 points. Okay? So for an absolute value, what you're going to do is you're going to plot the vertex as 1. So we move that vertex up 3 units. And then again, whatever we have right here, we just move this up 1, 2, 3 units too. And once you plot a second point, it will fill in the rest of the graph. And so this right here is our g function. That is the absolute value of x plus 3. Okay, I want you just to really quickly sketch the square root of x minus 5. Once again, it should be something that you can do pretty quickly. Keep in mind when you're doing the homework for these, you're going to have homework questions that are just identifying one thing, right? So it might just be vertical shifting. Then the next set of questions might be just horizontal shifting. Expect when you take the quiz that you're going to get the problems that come a little bit later that have all the different transformations applied to them. But as we start right here, we're just going to do one transformation for each graph. Okay, so here we're taking our original function here, absolute value, or the square root of x. We're moving everything down 5. So once again, 1, 2, 3, 4, 5. Plot that point first. And then if you find one other point that falls on a set of grid marks and you move it down, so let's say we take this and move down 1, 2, 3, 4, 5. And that's going to be the 2 points that give you your function. Now, when I give you the tools, the graphing tools for these, what you're going to see is you'll see sort of the generic functions for most of those toolkit functions. Okay? And so you will need to be able to identify which is the parent function, okay? Or which graph coincides with which of those parent functions. Okay? So next, let's take a look at what happens when that transformation happens inside the function. And notice the way that it's written here. F of x plus h, f of x minus h. If that quantity falls inside your function, okay, meaning it's inside the absolute value or inside the square root or inside this reciprocal squared or inside this quadratic, okay, now that represents a horizontal shift. Okay, and the way that I teach the horizontal shift is I have you ask the question, what value of x would give you a 0 inside your function? Okay, so when I look here at this, what value of x would give me a 0 inside the parentheses here? If x plus h, if I set that equal to 0. Yeah, negative h. So this one is going to tell you that you're going in the negative h direction. So you're going to go h units to the left. So you're going left h units, bless you. Okay, and what value of x would give you a 0 in this function? H. So h is positive. So we're going to move to the right h units if that's the case. It's whatever that value is that gives you a 0 inside your function is going to be the transformation in the horizontal direction. Okay, so here we take this red function. The red function right here is the reciprocal squared function. So we have y is equal to 1 over x squared. That's the parent function. And so when we take a look inside, we see that there's a transformation that happens inside our function, inside the x part. It's directly applied to the x itself. So what value of x would give you a 0 for this function here? Negative 2. So that means that this graph here is going to be shifted left 2, or negative 2. Okay, so that has to do with your shift, your horizontal shift. So what we're going to do is we're going to take all of these points here and we're going to shift them. So here is the asymptote. We're going to shift that 1, 2. There's no vertical transformations here, so everything else stays as it is. So your general graph is going to approach those asymptotes. Okay, we still have this asymptote here. Okay, and so that would be what the shifted graph looks like. And once again, you'll have a graphing tool for all the different possible graphs that you need to do. Okay, so I want you to sketch the next one here. Okay, what would your parabola look like if you were looking to graph x minus 3 quantity squared? Okay, so what value of x gives you a 0 inside your function? 3. So this is positive 3, which means to the right 3. Right? And usually I'll just use an arrow. So I'll say this is shifting to the right 3. So this vertex here gets shifted 1, 2, 3. And then every other point, again, just gets shifted the same 3.